everyone, once again welcome to our physics class. Hope you all are fine over there. Children, in the previous session we had discussed about Newton's second law and Newton's third law, and also we discussed the law of conservation of momentum. Today let's discuss some of the numericals of this chapter, mainly based on the law of conservation of momentum and Newton's second law of motion. So these numericals are very important. No separate notes will be provided along with this session since it is a numerical session. Just be ready with your notebook and pen and do the numericals along with me. Okay, pause the video for a while, note down the question and try to solve the numericals along with me. Children, some homework questions are also there, so do the homework. And if you have any doubt while doing your homework, please call me and clear your doubts. Okay, so before next Tuesday, you must submit your homework to the respective Gmail ID. You used to send your answers to one Gmail ID, right? So you are supposed to send or submit your homework to that Gmail ID. Subject of that mail should be physics homework. Okay, children. So let's get started with today's session. So children, let's discuss the numericals of this chapter. So this is the first numerical that we are going to discuss today. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meters per second. Calculate the initial recoil velocity of the rifle. So here, the mass of the bullet can be taken as m1. Okay, so let m1 be the mass of bullet and it is 50 gram. Then mass of rifle is taken as m2. So m2, mass of rifle, it is 4 kg and 4 kg can be written as 4000 gram. Okay, now the velocity of the bullet, it can be taken as v1. So here this velocity of the bullet is given as 35 meters per second. And which velocity is this? Is it an initial velocity or final velocity? It will be it will be final velocity, my dear children, because initially both the bullet and the rifle are at rest, isn't it? The rifle is at rest initially. So the initial velocity of the system will be 0. Only after the firing event, the bullet is fired from the gun, and as a result, the gun is moved back through a small distance and bullet moves forward. Okay, so only both the bullet and rifle starts to move only after the firing event. Before firing, both rifle and bullet will be at rest. So their initial velocity will be 0. So the initial velocity of bullet will be 0. But the final velocity of bullet is given as v1, that is 35 meters per second. Similarly, the initial velocity of the rifle will be 0 because initially both the system is at rest, and the final velocity of the the final velocity of the rifle, that we don't know. Okay, so here u2 means initial velocity of the rifle and v2 means final velocity of the rifle. Okay, so m1 means mass of the bullet, u1 velocity, initial velocity of the bullet, v1 final velocity of the bullet, m2 mass of rifle, u2 initial velocity of the rifle, and v2 final velocity of the rifle. And we need to find out the recoil velocity of the rifle. Recoil velocity means the velocity with which the gun or the rifle moves backward after firing. Okay, that is called the recoil velocity. So here we need to apply the law of conservation of momentum, and instead of collision we need to think about firing here. So the total momentum before firing is equal to total momentum after firing. Okay, so we can write like this: momentum before firing. Okay, momentum before firing is equal to momentum after firing. Okay, so how will you find out the momentum before firing? Momentum before firing will be 0. because initial velocity or before firing, the velocity of both rifle and bullet is 0. So the momentum before firing will be 0. And what is the momentum after firing? After firing, V1 is the velocity of the bullet and V2 is the velocity of rifle. So substitute the equation. Total momentum after firing will be momentum of the rifle plus momentum of the bullet, or momentum of bullet plus momentum of rifle. Okay, so what is the final momentum of bullet? It is m1 into v1. And what is the final momentum of the rifle? It will be m2 into v2. So we got 0 equal to m1 v1 plus m2 v2, and we need to find out v2. And from this expression, what is v2? So we can write m2 v2 is equal to minus of m1 v1, isn't it? So therefore v2 equal to minus m1 v1 divided by m2 equal to, substitute for m1 v1 and m2. What is m1? m1 is 50, v1 is 35 divided by m2. What is m2? m2 is 4000. Okay, then after simplification you will get the value. And sorry children, here one minus sign is there. I forgot to put this minus sign. So the final value is minus 0.4375. Okay, minus 0.4375. This is the recoil velocity. That means this is the value of V2. And what is the unit? Unit will be meter per second. So this is the answer, minus 0.4375. The minus sign indicates that it is a recoil velocity. That means it is the velocity with which the gun moves backward. Okay. So you can take a screenshot of this problem, or otherwise you can pause the video and note down the problem into your notebook. There won't be any separate notes for this session, so please pause the video and note down the problem to your notebook with necessary steps. Okay. Now this is the next numerical. Two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocities of 2 meter per second and 1 meter per second respectively. They collide, and after the collision, the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object. So here two objects are there. So let one object be taken as A and another object be taken as B. Okay, so two objects of masses 100 gram and 200 gram. So let the mass of A be 100 gram and let the mass of B be 200 gram. Now they are moving along the same straight line and direction with the velocities of 2 meter per second and 1 meter per second. So let the initial velocity of A be 2 meter per second and let the initial velocity of B be 1 meter per second. They collide. So collision is the event here, and after collision the first object, that means our A, moves at a velocity of 1.67 meter per second. So the final velocity of A is given, and after collision the velocity of the object A will change and the final velocity is 1.67 meter per second. Determine the velocity of second object. So you must find out the final velocity of second object B. Again, law of conservation of momentum. And what is law of conservation of momentum? Total momentum before collision is equal to total momentum after collision. So what is total momentum before collision? That is the initial momentum. So momentum of A, initial momentum of A plus initial momentum of B. That means initial momentum of A is MAUA plus initial momentum of B is MBUB equal to total momentum after collision. Total momentum after collision is final momentum of A plus final momentum of B. What is final momentum of A? It is MAVA Final momentum of B is MB, VB. Okay. Now substitute the values of MA, UA, MB, VB like that. So what is MA? It is 100. So 100 into UA is 2 plus mass of B, MB is 200 and UB is 1 equal to, again mass of A will be the same because through collision mass will not change, into VA is 1.67 plus mass of B, it is 200 into VB. We don't know the value of VB, we should find out VB. Now here simplify, 100 into 2 is 200, 200 plus again 200 into 1, 200. So 200 plus 200 is 400 equal to 100 into 1.67 is 167 plus 200 VB. Okay. So we will get 400 minus 167 is equal to 200 VB. Right? So from this you will get VB equal to 400 minus 167 divided by 200. And what is the value? Value is 1.165. Okay. And what is the unit? We are finding out the velocity, so unit will be meter per second. So after simplification you will get the value as 1.165 meter per second. Okay, here also you can pause the video and note down the problem to your notebook. This is the next numerical. A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Also find the force acting on it if its mass is 7 tons. And what is 7 ton? See, 1 ton is 1000 kilograms. So 7 ton will be equal to 7 into 1000. That means 7000 kilogram. Okay, we need to substitute the value of mass in kilogram. Now, a truck starts from rest. If it starts from rest, then initial velocity will be 0. And it rolls down a hill with a constant acceleration. If it travels a distance of 400 meters, so displacement is given. What is that? 400 meter. In 20 seconds, time is given. Time is 20 seconds. Find its acceleration. So you should find out the acceleration. Also find the force acting on it. After finding out acceleration, you must find out the force acting on that truck. Okay. So here, first we should find out acceleration. And to find out acceleration, you must use our second equation of motion, which is the second equation of motion. S is equal to ut plus half at square. Right? Because here u, s and t is given. So if you want to find out acceleration from these three data, you are supposed to use the second equation of motion, that is S is equal to ut plus half at square. Now substitute the values. S is 400, so 400 equal to u is 0, so this term will be 0 plus half a t. Time is 20, so t square, 20 square will be 400. Right? Then here this 2 and 400 will cancel, so you will get 200 here. So here you will get 400 equal to 200 into A. Therefore A equal to 400 by 200, that is 2. What is the unit of acceleration? It is 2 meter per second square. So we have solved first part of the question. We found out the acceleration. Next you should find out mass. Sorry, force. What is force? Force F is equal to ma. Then mass is given. Mass is 7 ton. Mass of the truck. 7 ton is 7000 kilograms. So here you can write 7000 into acceleration. Acceleration is 2. We found out the acceleration in the previous part. So 7000 into 2 will be 14,000. And what is the unit of force? It will be Newton. So the answer is 14,000 Newton. Okay, so children, pause the video and note down the problem to your notebook. Now, this is the next problem. A stone of 1 kilogram is thrown with a velocity of 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? So here, a stone of 1 kilogram is thrown with a velocity of 20 meters per second. So what is the mass of the stone? The mass of the stone is 1 kilogram and the initial velocity is 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. So distance S is 50 meters and finally the stone comes to rest. So the final velocity V will be 0. Now you should find out the force of friction. So anyway you must find out the force from the given data. So in order to find out the force, you require mass and acceleration, because force is equal to mass into acceleration. So you know the mass of that stone, but you don't know the acceleration part. So to find out acceleration, you must use our third equation of motion, that is v square minus u square equal to 2as, because only through that equation you can find out the acceleration value. So find out v square minus u square equal to 2as. So therefore a is equal to v square minus u square by 2s equal to v is final velocity, which is 0, minus u initial velocity is 20. So u square will be 20 square, that is 400, divided by 2s. S is 50 meter. So 2 into 50 equal to minus 400 by 100. Right? 100, and that is equal to minus 4 meter per second square. So what is acceleration? Minus 4 meter per second square. Now we can find out the force. Acceleration is minus 4, then force will be F is equal to ma, and mass is given. Mass is 1 kg. So 1 into acceleration is minus 4. So force will be minus 4 unit Newton. So this is the force of friction, and force of friction the negative sign in the answer indicates that it is a frictional force, because frictional force always directs in the opposite direction of motion. Okay, so you can pause the video and note down the problem. Children, this is the next numerical. A bullet of mass 10 gram traveling horizontally with a velocity of 150 meters per second strikes a stationary wooden block and comes to rest in 0.03 seconds. Calculate the distance of penetration of the bullet into the block. Also calculate the magnitude of the force exerted by the wooden block on the bullet. Okay, so what is given? See, there is a wooden block like this, and a bullet of mass 10 gram traveling horizontally with a velocity of, so a bullet is coming across this, coming towards this block, and it strikes this wooden block and comes to rest in 0.03 seconds. So on reaching somewhere inside the wooden block, the bullet comes to rest. Okay, so you must find out the distance of penetration into the block. So that means you must find out this distance, and also you must find out the magnitude of the force exerted by the wooden block on this bullet. Okay, so let's start. So here the mass of the bullet is given, and it is 10 gram, and 10 gram will be equal to 0.01 kilogram. Then initial velocity of the bullet is given, it is 150 meter per second, and finally the bullet comes to rest. So the final velocity is 0, and time is 0.03 seconds. Okay, this is the time, and you must find out the distance of penetration. So you must find out the distance using two equations of motion, either using s is equal to ut plus half at square, or through the second equation v square minus u square equal to 2as. But for both the equations you require acceleration, right? So acceleration is not given in the question. So first we need to find out the acceleration, and acceleration a is equal to v minus u by t. This is the equation to find out acceleration. That is equal to v is 0 minus u is 150 divided by t. Time is 0.03, and after simplification you will get the value of acceleration as minus 5000 meter per second square. This is acceleration. Now after getting acceleration you must find out the value of displacement. Yes, so what is the distance? You must find out the distance of penetration. So you can use the third equation of motion. That is more easy. V square minus u square equal to 2as. So therefore s is equal to v square minus u square by 2a equal to, what is v square? It is 0 minus u is 150. So u square will be 150 square divided by 2 into acceleration is minus 5000. Okay, equal to, when you simplify you will get the value of displacement as 2.25 meter. Okay, just find out the value, not through using calculator, but you must do all the calculations manually. You are not supposed to use calculator for your exams. Okay, so first part is over. We have calculated the distance of penetration of the penetration of the bullet into the block. Next, you must find out one more thing, that is you must find out the magnitude of force. So force equation is F is equal to ma. Then mass is given, mass is 10 gram, that is 0.01 kilogram. So mass is 0.01 into acceleration. Acceleration is minus 5000. Okay, so whenever you simplify you will get the value as minus 50, and since it is force, unit is Newton. So minus 50 Newton is the answer. Okay, so pause the video and note down the question. Now let's discuss the next numerical. A motor car of mass 1200 kilogram is moving along a straight line with a uniform velocity of 90 km per hour. Its velocity is slowed down to 18 km per hour in 4 seconds by an unbalanced external force. Calculate the acceleration and change in momentum. Also calculate the magnitude of force required. So here first of all just note down the data is given. Motor car of mass. So mass is given, mass is 1200 kilogram. Is moving along a straight line with a uniform velocity. That means initial velocity is 90 km per hour, and 90 km per hour you must convert it to meter per second. Okay, how will you convert it into meter per second? Just multiply it with 5 by 18. So you will get the value as 25 meter per second. Then its velocity is slowed down to 18 km per hour. So final velocity is 18 km per hour, and again you need to convert 18 km per hour to meter per second. So just multiply it with 5 by 18. So 18 into 5 by 18 will be 5 meter per second in 4 seconds, and time is given, time is 4 seconds. Okay, by a force, and you must find out the acceleration. So what is acceleration? Acceleration A is equal to V minus U by T, isn't it? And what is V? V is 5 minus U is 25 divided by T is 4. So 5 minus 25 is minus 20. Minus 20 by 4 is minus 5 meter per second. So the second square, acceleration unit is meter per second square, and it is a negative value, so it is a retardation because the velocity is decreasing with respect to time. Minus 5 meter per second square, that is our acceleration. Next you must find out the change in momentum. So what is change in momentum? Change in momentum is final momentum minus initial momentum. Okay, so change in momentum delta P is final momentum minus initial momentum. Final momentum is mass into final velocity. That means mv minus mu equal to, m is a common factor, so you will get the value of change in momentum as m into v minus u equal to, mass is 1200 into v minus u. V is 5 and u is 25. V minus u is 5 minus 25, that is minus 20, and that will be equal to minus 24,000, isn't it? So this is the change in momentum, and unit is kilogram meter per second. Kilogram meter per second, that is the unit of momentum. So minus 24,000. 24,000 kilogram meter per second. And you need to calculate one more thing, that is magnitude of force. So force F is equal to ma, then mass is 1200 into acceleration is minus 5. So 1200 into minus 5 will be minus 6000 Newton. Newton is the unit. Okay, so this is the value of or magnitude of force. Again, you can note down the question, pause the video and note down the numerical into your notebook. So children, these are some homework questions. So you must try to solve the homework questions and do all the homework in your notebook. If you have any doubt, you can ask me. And for the next live session, you must submit your homework. Okay, and I will give you the due date to submit your homework along with today's video lesson. Okay children, so with this I am concluding my session, and with this I am concluding our second chapter, force and laws of motion. Notes of the topic. So there won't be any notes or YouTube video based on this topic because we have discussed the numericals of this chapter. Okay, so we will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.